You might have experienced that your hotspot is alone in your hex, but the reward scale or the transmit scale is still less than 1. Or the configuration around your hotspot has not changed at all, but your reward scale still went down, and you are wondering why that happened. In this video, we will have an in-depth discussion on how reward scale or the transmit scale is calculated, along with a detailed understanding of hexes at different resolutions. Hey folks, this is Roy and welcome back to my channel, iCanTech. You might think that if you are alone in your hex at resolution 8, your reward scale of the transmit scale is always going to be 1. But that is not actually true. Let us check a few problematic examples. So here I am showing you a hex where there is only one hotspot, as you can see here, and there are no hotspots around this hex. The only hotspots are pretty far. So the reward scale for this one should have been 1, but you can see it's not 1, it's instead 0.69. So what's wrong here? Another example is I am showing you here. Let me turn on the transmit scale here. So you can see there are a cluster of hotspots here. These hexes have only single hotspots inside it, and these three have two hotspots inside it. So you can see that for this and this hex, the transmit scale is 1, but for some unknown reason, the hotspots in this hex have only 0.5. It shouldn't have been the case. It should have a reward scale of 1. So why is it so? So in the first part of this video, I'll give you a quick answer of how the transmit scales are calculated and what could be the problems. And in the second part, I'll give you a more detailed answer. For the quick answer, we'll go to the browser and type app.hotspotty.net. And once it loads, we can click on this search icon here and type the name of your hotspot. In this case, we'll check this problematic hotspot, and I have already loaded its information, and then you go to the reward scaling tab here, and that will show you some details about the rewards of this particular hotspot. So this is the net or total reward scale, which is 0.69. So let us now check the breakdown of the reward scale at different resolutions. So you might already know that to compute the reward scale, the number of hotspots at different resolutions are used. In particular, starting from resolution 10 all the way up to resolution 4. So in this case, you can see that the computed reward scale for different resolutions are mostly fine, starting from resolution 10 all the way up to resolution 5. But the problematic hex is resolution 4, and there are 363 too many hotspots. They are supposed to be so 800 would have been the optimal number of hotspots, and because there are 363 more hotspots, your reward scale is 0.69. You can check that. So the number is basically 800 divided by 800 plus 363, which is 1163, and that gives you 0.68787. So it's 0.69 approximately. So also this app is nice. It shows you in red color, the highlighted below, which one is the problematic hex. And you can see for the other cases, it says fully occupied, which is fine, which means that the number of hotspots in that resolution is equal to the optimal number of hotspots. And then there are 4 more available at resolution 7, 24 available at resolution 6, and so on. And on the top of this page, in the map, it shows you this colored hex shows you the problematic hex. Okay, so in this case, nothing can be done because the problem is at much larger scale, so there is no hope for this one. I'm showing you another example here where the reward scale is only 0.15, very bad. And in the breakdown, you can see there are problems at several scales, starting from resolution 10, resolution 8, 7, and 5. But what is important here, resolution 10 means it's really tiny space. And if you click on here, you will see that basically the two hotspots are very close to each other, and if one moves it slightly away, like reasserts the location, either this one moves here or this one moves here, the reward scale for this particular hex, which is resolution 10, will go to 1. And to compute the final resolution, what you have to do that you have to simply multiply to get the final or net reward scale or transmit scale. You have to multiply the reward scale at all different resolutions. That will give you the final reward scale. And The other problematic one, which one is this one, so elegant jet black zebra. I have also loaded it here, and you can see that the problem is only at resolution 10, which means two hotspots are really close to each other. You can see in this map it's very close. So in this case, the simple solution is to move one of these hotspots slightly away. So for example, let's say this one to hex A at resolution 10, and that will solve the problem. And you don't need to even physically move it, because this is very close distance. You can always set a location which is within 50 to 100 meters of the actual physical location, and that should still be fine in terms of earning or witnessing each other. I hope you now understand how to compute the total reward scale given the reward scale at individual resolutions, and you will be also able to perform diagnosis at which resolution the problem exists if your reward scale is not 1. If the problem happens at a very high resolution like resolution 10 or resolution 9 hex, then there is a chance to fix it by reasserting the location. But if it happens at a much broader resolution like resolution 4 or 5, there is not much hope, because it involves a much larger area, and you cannot change the location of other hotspots, of course. Alright, let us now move to the second part of this video, where we'll have an in-depth discussion on how to really compute the transmit scale. For that, first we need to have a good understanding of the hexagons at different resolutions. In this presentation, I am showing you hexagons at different resolutions, starting from resolution 11 all the way up to resolution 4. So higher the number means the finer it is, so the smaller the area, and a smaller resolution means a larger area. So if you talk about the arm length, it starts from 30 meter for resolution 11, for resolution 10 is 66 meter, and it goes all the way up to 22.6 meter, 6 kilometer for resolution 4. If you take the ratio between any consecutive hex, for example 66 meter by 30 meter, between basically arm length of the res 10 hex divided by res 11 hex is going to be 2.646, and it's going to be the same if you take the ratio of 1.22 kilometer divided by 461 kilometers. So basically this is the ratio of any two consecutive pairs, so resolution r hex divided by resolution r plus 1 hex. So this was the arm length. If you look at the area, which is more interesting, so area of resolution 10 hex divided by resolution 11 hex is going to be 7, and again it's going to be same for any two consecutive pair. So what does this 7 number mean? It actually has a physical meaning. So if we consider hexes as at resolution 8 and 7, these are not up to scale, and let us draw 7 resolution 8s which are contiguous in this fashion. Then you can see that the resolution 7x will look like this. So 7 resolution 8 hexes are enclosed inside one resolution 7 hex. Okay, and in this case we will call that resolution 7 is the parent hex and resolution 8 is the child hex. Okay, and if you now consider 7 resolution 7 hexes as shown by these green hexagons here, then the parent resolution 6 hexagon will look like this, and this is true for any resolution. So 1 hex at resolution R will be equal to 7 hex at resolution R in terms of area. Okay, we can have a better understanding of the hexagon decomposition by looking at an interactive map. For that, we will go to the browser and type helium.place. Then we will turn on the resolution 8 hex by toggling this button here, close it, and then zoom in to any location you prefer and let it load, and then I'll click on some spot here, and you can see that now this red zone is the bad zone where you should not have any other hotspot if there is a hotspot at the center, and these black hexagons are the resolution 8 hexagon. Okay, then let me now go here and turn on resolution 9 as well, and now you can see that inside one resolution 8 hex there are 7 resolution 9 hexes. Similarly, as I told you, it's true for any resolution hexes. So I will turn this off and turn the resolution 7 on, and then if you zoom out a little bit, you can see now that inside the resolution 7 hex there are 7 resolution 8 hexes. So the outside hex will be called the parent hex and the inside hexes will be called the child hex. Now this might look a little bit confusing because you can see that some part of this resolution 8 hex is outside the parent hex. Okay, but to see a more clearer picture, we can go back to the hotspotty page. Earlier I showed you this resolution 10 hexagon. Now we can go back and let's scroll down here and click on resolution 8 hex, and it will now show you the proper boundary. It looks like a kind of a flower shape. Okay, so this is how the actual this is the actual shape of the hex that is actually used in the calculations. But for the purpose of this video, we'll keep it simple and use regular hexagons as I showed you in the presentation. So the next important point is to understand the number of hotspots that is optimal for a given resolution, because that is the number which determines your individual reward scales. So there are some default numbers, which is so resolution 11 is not considered, only resolution starting from resolution 10 is considered, and the default number of hotspots is 1, and 1 for resolution 9, and then it increases slowly and goes to 250 for resolution 4. Okay, so I call this number enclip, which you can think as the maximum number of miners that can be present in a given hex before the transmit scale is reduced below 1. So if your hotspot number, for example, let's say at resolution 7 exceeds 6, the transmit scale of all of them will go down, and it will become 5 divided by 6. But this number is actually not static, it's dynamic, and that brings in the complexity. So the enclip value actually increases from this default value to a maximum value. It increases gradually and under certain conditions are met. And the maximum values are still, it's 1 for resolution 10, for 9 it's 2, 420, and for resolution 4 it's 800. Okay. In the later part of this video, we'll discuss how this enclip number increases from default value to this maximum value and under what kind of conditions. So let us now take the default values here and try to compute the transmit scale for a given hotspot. Okay, so I have grayed out the resolution 11 and it is not being used. And then this is showing you the enclip numbers, which are the default values. So here I have prepared a table and showing you the enclip number. It's the same numbers are here for different resolutions. Okay, and this next row is showing you the number of miners at different resolution hexes. So at starting from 10 up to resolution 8, there are only 1 miner. So basically, if you have a miner in any child hex, you will always have that miner in its parent hex. Okay, so in resolution 7 there are 8 miners, 20, 90 here and 300. Okay, so the formula to calculate transmit scale at individual hexes is given by this. So hex transmit scale is minimum of either 1 or enclip divided by n miner. So what it means that you have to divide enclip, this number, by n miner, and if this number is smaller than 1, then you use that number, but if this number is larger than 1, you use 1. Here one important point to remember is that the n miner is defined as the number of interactive miners. And the interactive miners means those hotspots which have location asserted and have whose beacon signals have been witnessed by other hotspots near. In other words, its beacon signal should have a valid witness, right? Okay, so those are the interactive hotspots, and non-interactive hotspots have always 0 reward scale. So so we can simplify this math expression and simply compute the ratio between enclip and n miner. So if it's greater than 1, we say it true. If it's less than 1, we say it false. In other words, if the number of miner present in a hex is smaller or equal to the number of optimal number of hotspots, it's true or green, and if it's more than that, it's false. So if it's true, you can consider that the transmit scale is simply 1 for that particular hex. But when it's false, you have to take the ratio. So in this case, 5 divided by 8, which is 0.625, and here 250 divided by 300, which is 0.833. And then to compute the net or total transmit scale, you have to just multiply all these numbers together. Since 1 doesn't matter, we just multiply 625 with 833, and that gives you 0.521. That would be the reward scale of this particular miner with this configuration. Now if you just simply let's say somebody else adds another hotspot at resolution 8. Okay, so it was earlier only your hotspot, but another hotspot comes here at resolution 8. So then you have to add one hotspot for all the resolutions up to, so from 8 all the way up to 4. And then since in this case this also becomes false, also you have to take the ratio between in clip and in minor here, which is 0.5, and other numbers slightly get modified. And now the total transmit scale will be the multiplication of the product of these three factors, and that becomes 0.231. So you can see that it changed drastically. Earlier it was 0.5 and now it became 0.23. It's just not a factor of 2, it's more than a factor of 2 in this case. So you can see the reward scale went down mainly because there was the limitation was only one hotspot at resolution 8 hex before the reward scale is clipped. However, this number in clip can change. As I told you earlier, this is a dynamic number. So in this next part we'll try to understand how that happens and when that happens. And in that case you have to also consider its neighbor. So in this picture I am showing you 7 resolution 8 hexes represented by blue, and then this is the hex under consideration where we are going to place our hotspot, and these are its neighbors. And the dashed line in purple shows you the resolution 7 hex, and notice that the neighbors can be placed in a different parent hex. Okay, so the parent hex for this resolution 8 hex is this one, the bottom one, but these ones have a different parent. So since there are no hotspots around, the in clip is set to its default value, which is 1. So if I now place one hotspot in this hex, your reward scale shown by color is going to be 1.0. However, if I place two hotspots, that is suboptimal, and that is why the reward scale is going to go down by a factor of 2 and will become 0.5 inside this hex for this particular hex. But this can change depending on the number of saturated neighboring hex. So I'm just using a term, saturated hex, which basically means how many neighbors are there which have a in minor, or the number of minors in that hex, larger than or equal to in clip, which is the default value, which is 1 here in this case. So here is a table which shows you that what should be this in neighbor value, after which the in clip can be upgraded, and it has different number for different resolutions. So we are considering resolution 8, that is why I have highlighted it in bold. So it has to be 2 in this case. So right now in neighbor is 0 because there is no hotspots around it, so which is less than in saturation. So the in clip is still going to be 1. Now I place another one in its neighbor, so that reward scale is going to be 1.0. However, since in neighbor is 1, which is less than in saturation, in clip is still going to be 1. So this reward scale doesn't improve. Now I place another hotspot at its neighbor, another neighbor. Now in neighbor is equal to 2, which is equal to the in saturation. Okay, and so these numbers are all chain variable numbers which I have picked up from HIP17 information. And now this in clip can be upgraded because it satisfies this condition. It becomes now 2, and thus this reward scale no longer need to be 0.5, but it becomes 1.0 now. Okay, so now I can further increase it. So if I place another hotspot in another neighbor, so now in neighbor is 3, so in clip can also be 3. So you can place 3 hotspots inside the resolution 8 hex without the reward scale being brought down. Okay, you add another, it becomes 4. But can it keep increasing? Can you place like 6 neighbors and can this become 6? No, because there is again a limitation on this, which is represented by this in max number, and again it is different for different resolutions. For resolution 8 this is 4. Okay, but that means that even if I place 5 hotspots in its neighbor, the maximum number of hotspots that I can place here without the reward scale being brought down is still going to be 4. So with 4 hotspots you can still have reward scale of 1. Also in this scenario the situation for other hexes also improve. For example, for this hotspot you have 2 neighbors with having more than 1 hotspot, so it can have now at maximum of 2 hotspots with a reward scale of 1.0. Similarly, this hex has 3 neighbors, and so that this can have 3 hotspots inside it. Similarly, this one 3, this one 3, and this one 2. Okay. If you now increase another hotspot here, since enclip has been maxed out, it's still 4, your reward scale is going to go down. The factor will be 4 divided by 5, which is 0.8. So if you place, for example, 6 hotspots here, it will be 3 divided by 6, which is 0.5. And again, if I increase the number of hotspots in this hex to 10, because the number of allowed hotspot was only 2, the reward scale for each of the hotspots becomes 0.2. And so note that these numbers are obtained by considering there are no other hotspots around it. And then finally, these are the transmission scales for this particular resolution, which is resolution 8. But to get the final or net transmit scale, you have to take the product of transmission scales at all resolutions, as I showed you earlier. So, and even though I showed you this particular example for resolution 8, the same explanation holds for all the resolutions, but the number in saturation and in max will be different, and these are the chain variable numbers. Okay. Another important interpretation of this table is that under no circumstances a hotspot can have a reward scale equal to 1 if the total number of hotspots in that hex becomes larger than this in max number. For example, if you consider resolution 6 hex, if the total number of hotspots in that resolution hex becomes larger than 100, all hotspots inside that hex, including its child hexes, the reward scale is going to be smaller than 1. Okay. Now I will answer a few commonly asked questions. The first one is, what is a good reward scale? In this table, I have divided the reward or transmit scale in 5 different categories. Anything between 0.95 and 1 would be excellent, between 0.75 to 0.95 would be good, mediocre would be 0.5 to 0.75, 0.25 to 0.50 is poor, and anything below 0.25 is terrible. Okay, so you'd like to be in the range, you like to have a reward scale in the range of 0.75 to 1. The second question is, how does the reward scale affect your earning? So actually, the reward scale of your hotspot doesn't affect your earning directly, it rather affects the earning of other hotspots in your vicinity. So basically, whenever you send a beacon signal and it is received by other hotspots as a valid witness, the earning will be scaled down by the factor of your transmit scale. However, it can affect your earnings indirectly, so let us check that. So here is a 7 hexes at resolution 8, and this is the distribution of hotspots. Since there are 2 neighboring hotspots have the saturated, the enclave for this hex is going to be 2, and there could be 2 hotspots with a reward scale of 1. So if this hotspot sends a beacon signal and received by this hotspot, then with a valid witness, let's say it can earn 0.1 HNT. Okay. This is because the reward scale is 1, it will not be scaled down. Similarly, another witness by this hotspot will also earn 0.1 HNT. However, let's say these 2 hotspots are pretty close to each other, let's say within resolution 10, then you know that the reward scale is going to go down to 0.5 as I showed you earlier in the presentation. And in that case, what will happen that the beacon signal sent by this hotspot will be received by this, but it will become an invalid witness because saying that it's too close to each other, or most likely the RSSI value is too high. So you can see that the reward scale has indirectly affecting your earning because you can no longer earn from this hotspot. So it's saying that in that case the reward scale is saying that there are other hotspots in your vicinity and one needs to move those around to either you have to move yours or the other people have to move theirs. And also in this case, this hotspot also earns less HNT. It could have earned 0.1 earlier, but simply because bad location assertion, this one will earn now 0.05 HNT. And that is how you can see that the earning of the neighboring hotspots is affected, but you can still lose witnesses, and that is how you can lose your earnings. And the third question is, how frequently is this reward scale updated? It can get updated whenever a new hotspot arrives in your hex. So it could be any starting from resolution 10 to all the way up to resolution 4. So if a new hotspot comes or the location is asserted inside that hex, the reward scale might get updated. Similarly, if a hotspot loses or gains its interactive status, as I explained earlier, the reward scale can get modified as well. And you can expect the reward scale changing a few times a day. I hope with this information you will be now able to understand how the reward scale is calculated and then also perform diagnosis at what resolution level the problem exists if your reward scale is less than 1. And again, to reiterate, if the problem or the reward scale is small at the higher resolution like resolution 10 or resolution 9, you can most likely fix it by simply reasserting its location. If it happens, if the problem exists at a much larger resolution like resolution 4, 5 or 6, you cannot really do anything because it involves so many hotspots in a very large widespread area. I hope this information was useful to you and clarify some of your doubts. If you have any more questions, let me know in the comment section. That's all for today. Thanks for watching guys, and get cryptonized.